Hey guys, happy Tuesday. I hope you enjoyed your nice long weekend. Today we are going to be continuing section 6.3, solving systems, but we are going to use our graphing calculators. So you want to title your note 6.3 day 2, solving systems. Using a graphing calculator. So this means you need a graphing calculator. We've got two options. And I can't write and talk. Okay, so option 1 is your own calculator. Now this is the most ideal option. So if you have a TI-84 at home or a TI Inspire, I have posted instructions on my website on how to use them. So you should have those out or written down, and you should be doing it and practicing it in your graphing calculator. That's the ideal way, because when hopefully all of this is blown over, you know how to use it. The other way is Mr. Everett made a tutorial video on how to use Desmos to do matrix multiplication and everything. So you can watch that YouTube video before taking the notes. In my notes today, I'm assuming you've already looked through these two things, and so you're gonna, I'm gonna be quick about going through the problems. So first of all, we're gonna have some steps that are required. Shouldn't come as a surprise. So when we're solving systems, the first thing you want to do is put your matrix into a matrix equation. Or sorry, put your system into a matrix equation, which we have been doing. So that's the AX equals B, and that's going to be similar. The second thing you're going to do is set up, or show your X equals the A inverse times B. And remember the reasoning. So we start with AX equals B, and to get rid of X, we multiply by the inverse on both sides, because then we'll be left with the identity matrix times X, which is like multiplying by 1. All we're going to require from you is that you show this line. Okay, and then the third thing, you're going to solve using your graphing calculator. And then make sure you write your answer in 2 ways. The first one is as a matrix. And the second is as a point. Because remember, a solution to a system of equations is the coordinate point where it's intersecting with all of the equations. So let's do an example. Now here's the reason we're showing you how to do this in a graphing calculator, so that we can have a system of equations with more than 2 equations. In the past, you guys have only really worked with 2 equations, but now you can work with more. So, first equation, negative 6y plus 3x plus z equals 15. Second equation, negative x minus 2y plus 4z equals 12. And our last equation, 5y plus 2x equals negative 1. Now, the first thing I would do in this situation is rewrite this, because the order matters. Remember, we needed to go like x, y, z, or y, x, z, but they all need to be the same. So I'm going to do x, y, z because I like alphabetical order. So that'll be 3x minus 6y plus z. Then we have negative x minus 2y plus 4z. And the last one is interesting because there is no z, so we can put a 0 there. We still need a placeholder. Now, required line is the ax equals b, and we want you to label it. So my A matrix is made up of that left side of the equal sign, and remember the order matters. So I'm going to have my x value, my y value, my z value. And that's the coefficient. So then -1, -2, 4, 2, 5, 0. So this is my matrix A. X is our variables, and we went in order, so x, y, z. And then it equals matrix B, which is the right side of the equal sign, so the 15, 12, -1. So it's required that you write this all out, and it's required that you're labeling the A, the X, and the B. Now, the next step is to do A inverse, or well, X is going to equal A inverse times B. So what we need to do next is we need to figure out A inverse. So what we're going to do is in our graphing calculators, we're going to create matrix A and raise it to the -1st power. So I just did this in my calculator. I'm just going to label this on the top. X equals A inverse B. So X is X, Y, Z. And in my calculator, I found out A inverse, and it's a lot. So I got 20 over 109, -5 over 109, 22 over 109, -8 over 109. I'm going to have to make this bigger. 2. Oh, fell asleep. 13 over 109, 127/12 over 109. Okay, so that's my A inverse matrix. And I'm multiplying that by my B matrix, which is, 15, 12, -1. And now I'm going to do that in my calculator, because I don't want to do it by hand, which is the beauty of the calculator. And I am left with the matrix 2, -1, 3. So that means my x value is 2, my y value is -1, and my z value is +3. So we're going to write it as a point, which this is 3-dimensional because there's 3 variables. And that is it. All of this work that I have shown is required, minus the rearranging, although you'd be really silly to not show that. It's easy to mess up if you're not showing it, so why not? Okay, so now that we've gone through an example, why don't you try and let's see. I would like you to do the following. So we have x plus y minus z equals -5, 2x plus 2z minus 3y equals 20, and 4z plus y equals 18. So pause the video and try to do this one on your own. Alright, so first things first, I rewrote this. Oops, sorry, dropped my Surface. I rewrote this. So the order was in XYZ equals form. Required work showed AX equals B. Used my calculator to determine A inverse. I forgot to write that. Whoops. So X equals A inverse B. Also required. Used my calculator to multiply the two, got my final matrix, and then rewrote my final answer as a point. So hopefully you guys also got 2, -2, 5, and that is it. We're done. So I believe we threw in an application problem in your homework tonight, maybe, or we're saving it for tomorrow. Either way, you've done application before. The hardest part is just setting up your matrix, so be careful. And then as always, please come to Flex Time if you have any questions or need any help. And we are done. Have a great day, guys.